Okay, we start with three forms of a line. Point slope form, the point is x1, y1. And this is actually the most convenient form for a line if you're given a point, or 2 points for that matter. The slope, as always, is m. Slope-intercept form is named because you got the slope and the y-intercept, which means how high up or down on the y-axis it hits. Standard form we don't spend a whole lot of time with, but it's useful for finding both intercepts on a graph, and so we'll practice that a bit at the bottom of the page. Technically, you have to have various things like A, B, and C not having any factors in common and things like that, but again, not going to worry too much about that. If you're looking at problem 2, y equals 5 is horizontal. So to be parallel to a horizontal line, you need another horizontal line. That means it needs to be y equals a constant. What constant? Oh, look, there's a constant. Y is 1. What do you do with the 4? You ignore it because it doesn't care what x is. Through 4, 3, you want to start by starting with point slope form. The y-coordinate goes closest to y. Fill in the space for the slope in a minute. X-coordinate goes closest to x. What is the slope? Well, if it says parallel, you actually just rip the slope off. Make sure you don't write the x down. So it's y equals 3 minus 3 halves x minus 4. And I don't really care if you write plus negative or just subtract 3 halves. Okay. If you're going to write an equation of a vertical line, you need x equals. What does x equal? Oh, look, x equals 5. That's a vertical line. Through 6, 2, you need to figure out what the slope is. The original slope is negative 4/3. The perpendicular slope, you probably remember from Algebra 1, you take the opposite reciprocal. So flip the sign and flip the fraction. If it's a whole number, make it 1 over the number instead. Okay, so positive 3/4. I'm not going to write the extra plus sign, but 3/4. Through 2 points, you can use either point for point slope form, but what you end up doing for the, you need to find the slope. So let's find the slope. y2 minus y1 over x2 minus x1. Does it matter which one comes first? No, but if you pick a y1 to go first, or a y2, then the corresponding x has to go first on the bottom. So if you pick 1 on the first on the top, 5 has to go first on the bottom. Some simple arithmetic. Okay, pick either point. I'm going to use 4, 7. The y-coordinate is 7. Slope is negative 6. And again, I'm not really fussy about if you write plus negative 6 or just subtract 6. The x-coordinate goes closest to x. All right, so if we're going to graph to find the slope, the nice thing about standard form you can plug in 0 for either variable and get both intercepts. We've seen this in class, but let's do it officially. So if x is 0, then you have 3x, which is 0, minus 4y is 12. So y is negative 3. Yes, y is negative 3. That's spiffy. If y is 0, you have 3x minus 0 is 12. So x is 4. Plot those 2 points, negative 3, 0, negative 3. and positive 4 is 0. And oh look, the slope is 3/4. So I'm just going to keep going up 3 and over 4 until I run out of graph paper. And draw the line. In order to easily draw the second line, I think I need to divide everything by 2. Don't forget to divide the x term by 2 also. Okay, so up 7 to start with, and then down 1 over 2. And, oh, look, I find the intersection. Don't forget to actually write it. Looks like it's over 8 and up 3. And remember that points have parentheses. Thank you. All right, to solve with substitution, we solve for one letter in one of the equations. It doesn't matter. I usually look for something where I don't need fractions. So if I look in the second equation, and I move the x over, so instead of having negative x on the right, it's x plus 2y on the left, I can easily solve for x. X is 14 minus 2y. When you solve for one of the variables, again, it doesn't have to be y, you plug it into the other equation. Make sure you're not plugging it into the same equation. What's the other equation? It's the 3x thing. So 3, turn x into 14 minus 2y. 3x minus 4y equals 12. Now I have the equation with just y's. Distribute the 3. So 42 minus 6y minus 4y is 12. 42 minus 10y is 12. I'm going to subtract 32 from both sides.
Uh-oh. There goes the sound. Negative 10y is negative 30.
12 minus 42 is negative 30. We know from the substitution equation that x is 14 minus 2 of those. So 14 minus 6 is 8. Okay. With elimination, you need to make sure everything lines up in the same order. So if I have 3x minus 4y equals 12, with x first, then y, then the equal sign, and the constant by itself on the other side of the equal sign, I need to make the other equation look like that too. So I'm going to have the x plus 2y equals 14 version. I can either multiply by 3 and get rid of the x's, or multiply by 2 and get rid of the y's. I think that's what I will do. Multiplying this equation by 2, don't forget to actually write the other equation down. Doubling the second equation, I have 2x plus 4y. I always set it up so that when you add, it cancels. Okay, so I'm adding to cancel the 4y's. So 5x is 40. Oh, x is 8. Plug that into either of the other equations. I'm going to plug it in here. So 8 plus 2y is 14. Subtract off 8. And y is 3. And we have 8, 3 again. Yay.